All right, 4.3 matrix multiplication. Now, so far we've done the plain old just matrices and looking at elements. That was in section 1. Section 2 was addition and subtraction, and now we're in section 3. I hope that section 1 and section 2 have been pretty easy for you. Section 3, I think, is where it gets a little bit harder. So starting off, the easy kind of multiplication, scalar multiplication. Oops, is my pen going to work? There it is. Okay. That's where you multiply a matrix by a scalar or a constant. It will be written something like 5a, right, where a is a matrix. And what you do there is you just multiply every element within a by 5, or whatever number is there. Sometimes it'll be like a 1/3 a. And in that case, you either multiply or you could think about dividing by 3, each element in there. Matrix multiplication, though, this is where it gets much more tedious, maybe is the word. Multiply the element of each row of the first matrix by the element of each column in the second matrix, and then add the products. Now, I don't expect that to make a whole lot of sense right now. I'm going to do it, and hopefully you will understand whenever I do it. But for starters, we need a couple more definition stuff. What is the dimension of a product matrix, right? If we have A times B, what is the product? What is the dimension of the product going to be? Well, starting off, if we say that matrix A is a M by N matrix, remember we have rows by columns, and matrix B is a N by P matrix, then the product matrix AB is a M by P. Now here I wrote it out here, and I think it makes a whole lot more sense. We have matrix A and matrix B. A is an M by N, and B is an N by P. Now notice, they both have N's in the middle of it, right? For A, the columns are in, and for B, the rows are in. Those have to be the same for them to multiply. Okay, so multiplication of two matrices is not always possible. You cannot always multiply two matrices, right? The result, you take the first, the M, and then you have P being the ending. It's an M by P, right? The note, as I just said, the number of columns in matrix A has to equal the number of rows in matrix B. That was the N in our example there. So let's do a couple examples and we'll see if it makes more sense. A is that there, B is there, and we're supposed to find A times B. So starting off, I'm going to write them as just right next to each other. So I have -1, 0, 3, and -4. -3, 3, 5, and 0. Now these are both, we should talk about dimensionality or the dimensions. These are both 2 by 2s. Right. The insides are both 2, so we're good. We're able to multiply these together, right? If those aren't the same number, then you have to say you cannot multiply them. On the homework, it says to say product undefined, okay? Our new matrix is going to be a 2 by 2. Now, we take the rows of the first one, that row, times the first column. So the first row times the first column. So I'm going to take -1 times -3 plus 0 times 5. And that's going to be the first element in our new piece. Now I stay with the first row, and I switch to the second column. This will be -1 times 3 plus 0 times 0. Now I jump to the second row. 3 times, oops, I also have to do this one. 3 times -3 plus -4 times 5. And lastly, I do the bottom row with the last column, 3 times 3 plus -4 times 0. All right. I think the process that I just now showed you is the most difficult part of the lesson. That's the most difficult piece to remember, right? You go across the row and down the column, right? If you have trouble with that, hang tight with me and watch the rest of the video. And if you're still confused over it, you might want to go on YouTube and find a couple more videos over that. So now we've done the hard part of it, and we just need to simplify it together. So this will be 3 plus 0, -3 plus 0, -9 minus 20, and 9 plus 0. Together that gives me, what is that, 3, -3, -29, and 9. And there's our matrix. There is A times B, all right? Next up, another multiplication. We have A and B here. Starting off, we need to decide, can we multiply these? The rows, we'll do the first one first. This is a 3 by 2, right? 3 rows, 2 columns. And the second one is a 2 by 4, 2 rows and 4 columns. The middle numbers match, so we're good. We can multiply these. And these are going to be our result is going to be a 3 by 4 matrix, right? 3 units tall and 4 units wide, or 4 elements wide. So, how do I want to do this? I'll go ahead and write this out. A is going to be 2, 1, 7, -1, 4, 2. And B is 2, 7, 5, 9, -1, 5, 14, 0. Our new one's going to be 3 tall and 4 wide. I'll put the ending bracket there in a second. Now again, just like in the last one, and this one makes it a little bit harder because it's a little bit longer, we go across the rows and then down the first column. Right? So this will be 2 times 2 plus 1 times -1. Our second piece will be the first row again times the second column. So 2 times 7 plus 1 times 5. Next up, 2 times 5 plus 1 times 14. And then lastly, I'm going to have 2 times 9 plus 1 times 0. Right? We have done one row now, right? Next up, we go on the second row, first column again. So this will be a, what number is that? That's a 7. 7 times 2 plus -1 times -1. Then we'll do the second row and the second column will be 7 times 7 plus -1 times 5. Next up in the gray, we will have 7 times 5 plus -1 times 14. And then lastly, we will have 7 times 9 plus -1 times 0. Right? Last step, I'm going to have to reuse some colors. We have 4 and 2 with the first one. So it'll be 4 times 2 plus 2 times negative 1. Then again, we use the 4, 2 row with the second column. Will be 4 times 7 plus 2 times negative 1. Oops, I'm sorry. 4 times, oops, that shouldn't be a negative 1. I looked at the wrong spot. That should be a 5. In the light blue, I use the last row and the third column there. So this is going to be 4 times 5 plus 2 times 14. And lastly, that last column in the last row will be 4 times 9 plus 2 times 0. Some things to notice to help you out. Those are all 2's. Those are all negative 1's. 7, 5, 5, 14, 9, and 0. Right? If you always go in the pattern that I went in, where you go from the first one, or you write the element from the first matrix first and then the second one, you'll always have that pattern there, right? That's actually how I caught myself mess up right there at the end. So I think you should write all your work out, do it the same way that I do, because it helps save some mistakes, I think. All right, now for simplifying. 2 times 2 is 4, and then it'll be a minus 1. 14 plus 5, 10 plus 14, 18 plus 0, 14 plus 1, 49 minus 5, 35 minus 14, 63 plus 0, 8 minus 2, what is 7 times 4? 28. 28 plus 10, 20 plus 28, and 36 plus 0. Lastly, we just perform our addition there. So it'll be 4 minus 1 is 3. 14 plus 5 is 19. Then it'll be 24, and 18, 15, 44, what is that, 21? Is that 21? Yeah. And then 63, then 6, 38, 48, and 36. And there we are. We are finally done, right? I understand that these are long problems. They will take a while. You do have quite a few homework problems over these, because I think the only way to really learn how to do these is to just do them a lot of times, okay? So you do have probably, I don't know, what is that, 10 problems or so that do something very similar to this. All right, lastly, back to an easy thing. Scalar multiple. We have matrix A, and our scalar is C here, right? It's just the negative 1/2. So here, to write this in, like write it all together, I'd have negative 1/2, then my A, which is 1, 2, 3, 4, 5, 6, a nice and original matrix. And think of distributing right now, right? You just kind of distribute the negative 1/2 into everything. So this will be negative 1/2, negative 1, negative 3/2, negative 2, negative 5/2, and negative 3. Right? Nothing crazy. Actually, I think that's pretty easy, especially in comparison to what we did. So that's all for this lesson. I want you all to know that if you do go on Google and you look for matrix multiplier or matrix multiplication or something like that, there are calculators online to let you do this. For your homework, for your tests, you have to show all of your work, right? All of your work. For this example that I have pulled up here, you could have this step or this step. You have to have one of them. I think it's good to have both of them. But if you don't have either of those and you just jump to the end, I will be marking it wrong. Okay, that goes for homework and that goes for quizzes and tests. So you need to show your work. You need to show me that you know what you're doing. okay? Same way for here. Here's a step, and there's a step. You could have one of them, you could have both of them, but you cannot have neither of them, all right? So that's that. Good luck on the homework, and let me know if you have any questions.